All right, so hopefully this will help you on your work tomorrow, working on solving radical equations. So equations that have radicals, specifically square root equations here, it's going to be a lot of squaring both sides. That's the typical approach for undoing a square root. So here you actually, there's not much work to do. And the problem says, hey, when they solved this equation, it looked like they got two answers, x equals 10 and x equals 2. Then they're telling us one of the solutions is extraneous. So an extraneous solution is a solution that works for the squared problem, or some it works for some part of the equation further down the line, but it doesn't work in the original equation. Um, so they went through and solved it, and they got x equals 10 and x equals 2. And so, really, all they want us to do in this question is to check it. Let me show you how you could have gotten x equals 10 and x equals 2. It's a lot of work. So I'm going to take this, I'm going to isolate the radical. So I have square root of 2x plus 5 plus 5 equals x. I'm going to subtract 5 from both sides. And now I've isolated the radical. Square root 2x plus 5 equals x minus 5. I'm going to get rid of the square root, right? That's going to be a problem. So I'm going to square both sides. Square, square. So this squaring this is easy. I get 2x plus 5. Squaring this is still kind of easy. It'll be the square of a binomial. It's going to be x squared minus 10x plus 25. Now I have a quadratic equation. We need to get everything to one side or the other. I'm going to subtract 2x, subtract 5 from both sides, minus 2x minus 5. So I get 0 equals x squared minus 12x plus 20. So I need two numbers that multiply together to give me 20 and add up to give me negative 12. And since they multiply to give me something positive, they either have to be both negative or both positive. They combine to give me negative 12. So I know they both have to be negative. The most obvious pairing is negative 2 and negative 10, and that is, in fact, the pair that works here. So x minus 2. And that's actually fitting with what they came up with for the solutions. And x minus 10 equals 0. So that yields x equals 2, x equals 10. These are the solutions to the equation when I squared both sides. But squaring both sides might introduce this idea of it worked in the later version, but not in the original version, because maybe you had 3 equals negative 3. Well, if I have 3 equals negative 3 and I square both sides, I get 9 equals 9. Oh, of course, 9 equals 9, but 3 doesn't equal negative 3. So sometimes the squared version works when the original version plugging in wouldn't have worked. You were not asked to do this. I was just showing you the process, and could get even uglier. All you're asked to do is check it. So let's plug in 10 and see if 10 works. So 10, let's plug it in down here. We get the square root of 2 times 10 plus 5 equals 10. Let's see. This is 25. The square root of 25 plus 5, does that equal 10? Yes, it does. So 10 is actually a solution. 10 is good. 10 works. Let's try 2. So I plug it down here. The square root of 2 times 2 plus 5. Let me extend my radical here. Plus 5 equals 2. So I think we're going to have a problem because this would, in order for this to be true, this would have to be a negative number, right? This does equal 9. The square root of 9 plus 5, is that equal to 2? No. However, if this were a negative, right, a negative 3 plus a positive 5, it would have worked. Okay, so this one here is the extraneous one. It works later on, but it doesn't work in the original problem. Okay, so when checking solutions, square root contains a negative radicand? No. No, it didn't. When I plugged in both numbers, the radicand was still okay. Radicand, by the way, is the number underneath. It was positive in both cases, so that wasn't the problem. X equals 2 is the extraneous solution, yes. X equals 10 is no. When substituted into the original equation, the extraneous solution results in a false statement. Yes, that's what it means to be extraneous. It doesn't work in the original equation. Okay, This is messy. So I need to square both sides, but the problem is when I square both sides, I'm still going to have a radical in the problem. The reason I included this in our examples is because it's so much work, and I'd rather I have a shot at doing it. Okay, so we need to isolate the radical. Well, the problem is I have two radicals, and you can't isolate them. So then I'm gonna the next best thing is I'm gonna put one radical on one side. I'll put the more complicated radical by itself. So basically, I'm gonna add this to both sides, the root x. Um, so when I add root x to both sides, plus root x, I'm going to get root 2x minus 2 equals root x plus 1. Now I'm going to square both sides. Oh, this is easy. 2x minus 2. What are you worried about, Mr. Hanson? Oh, shoot. What is this when I square it? So this is going to be, let me use the box technique over here. You could use whatever technique. So square root of x plus 1, square root of x plus 1, square root of x times square root of x is x. Okay, that seems okay. Square root of x times 1 is root x, and I have another root x, and then 1 times 1 is 1. So I have two root x's, so plus 2 root x's plus 1. Okay, so now I still need to get rid of this radical. I'm going to have to square it again. Every time you square both sides of an equation, you are even more likely to introduce extraneous solutions. So let me try to isolate the radical here. I'm not going to totally isolate it because it's got a 2. I don't want to introduce fractions. Might be that I don't, but I think I will if I were to continue to do this. So I'm going to minus x from both sides and minus 1. So that's all I'm going to do. So minus 1 minus x. So I get x minus 3 equals 2 root x. And like I said, I'm not going to divide by 2 because I don't want to introduce a fraction. So at this point, I'm going to square both sides again. So x minus 3 squared and 2 root x squared. This is going to be 4x. This is going to be, so it's a lot of work, x squared minus 6x plus 9. I guess not too bad. And now I'm going to subtract 4x from both sides and now have my normal quadratic equation, minus 4x. So this is going to give me x squared minus 10x plus 9 equals 0. This does factor. So two things that multiply together to give me 9 and combine to give me negative 10. I know they both have to be negative, and it turns out it's x minus 1 and x minus 9 equals 0. So it's x equals 1 or 9. Okay, so now let's go back up and check and see if it works. So let's plug in 1 first, because that's the one over here on the right. So we have the square root of 2 times 1 minus 2 minus the square root of 1 equals 1. So here I get 2 times 1 minus, I get 0 minus 1 equals 1. That is not true. 0 minus 1 is negative 1. If I had negative 1 equals 1 and I square both sides, yay, I made it true, but it's not true in the original one. So x equals 1 is extraneous. Yeah, whatever. Okay, so that's not a solution. Let's cross our fingers, hope that 9 is the solution. I'm feeling better about 9. So let's check and see. Now let me just erase all this. Okay, so, and you can play back the video, right? So the square root of 2 times 9 minus 2 minus the square root of 9 equals 1, hopefully. This is 18 minus 2 is 16. The square root of 16 minus the square root of 9. This is 4 minus 3 equals 1. Yes, that means 9 is the solution. X equals 9 is, in fact, the only solution because there was an extraneous solution. Lots of algebra here, but, you know, we can do it. Okay, last problem here. We need to take this and solve it for r. I need to get the r by itself. Okay, so what do I need to get rid of? I need to get rid of this iu. I need to get rid of the radical. I need to get rid of the m. Which do you get rid of and in which order? You need first to try to isolate the radical. The radical is being divided by n. I'm going to multiply both sides by m. So we get MCE equals, and these are canceled here, square root of r minus IU. I can't add IU to both sides until I get rid of this radical. This acts like it's a package deal. All this stuff is together until I eliminate this radical. I get rid of the radical. It works a lot like parentheses. So how do I get rid of a radical? Square root. I'm going to square both sides. And again, when I'm squaring both sides, I might be introducing some logical fallacy. This is a literal equation that I'm solving. So it's hard to go back and check and see if I'm getting extraneous solutions, but you may be introducing some extraneous behavior. So I get, I'm just going to leave it like this, MCE squared. I could say M squared, C squared, E squared equals R minus IU. And now I need to get the R by itself. So I'm going to plus IU to both sides, plus IU, and just leave it like that. MCE squared plus IU equals R. Done. Big deal. Not that big of a deal. All right, y'all. Yeah, take a look at this video. Maybe watch it on 3 times speed or 5 times speed. That way you can maybe tolerate it. All right. See ya.